Okay, this first lesson in geometry, chapter 1, lesson 1, is all about points, lines, and planes. And it talks about defining these terms as well as being able to sketch, label, and identify any of the objects in a figure. So, the first thing we want to start off with is what we call undefined terms. These are called undefined terms just because they are kind of like duh, like they're already understood what they are, and they really don't have any formal definition. But our first one is a point. A point is just simply represented by a dot. And then we have a line that exists through any 2 points. So no matter where you have 2 points, you're going to have a line that exists. And it has arrows at the end to represent that it goes off infinitely in both directions. And then thirdly, we have a plane. It exists through any three non-collinear points. We will talk about that term non-collinear here in a little bit. Pretty much it means that these 3 points, they can't all be on the same line. Two of them can, but not the third. And we represent that plane. Usually you think of like a wall, the smart board, but it's usually drawn like a parallelogram. It's just representing a flat two-dimensional surface. So then we do move on to our defined terms. Now the defined terms use some of those undefined terms in their definition. So we first have array. Array has one endpoint and it extends infinitely in only one direction. So it has that endpoint and then it'll go off infinitely in that direction. The second is a line segment. So a line segment we did talk about last week with our Desmos activity, but it's part of a line that is bounded by two distinct endpoints, and it actually contains all the points in between each of the endpoints. So if I have a line technically could have an infinite amount of points too. Right here I just have a line. It exists through 2 points. So I could talk about this line as it is by itself, or I could just talk about this region bounded by the two endpoints. I'm about to draw it here in red. So I could just talk about that segment that's bounded by those two endpoints, or I could talk about the line itself. So there's actually two images there. So now we have collinear points and coplanar points. So think about co meaning together, and then in that word collinear, I see the word line. So they're literally points that are together on the same line. So I could draw some points that are on these two lines right here. These lines are actually intersecting, but I could have point A and point C. So A and C would be collinear. They would also be collinear with point M. But if I do draw some other other points on the other line, so it still has point A though, point A, L, and P are collinear, but P is not collinear with M. And then coplanar points, similar, co means together, and you see the word plane, so they're points that lie on the same plane. And then the last one we have is something called opposite rays. So remember from before, rays have one endpoint and extend infinitely in one direction. Opposite rays have the same endpoint, but they extend, they are collinear, before I go further. So they have to be on the same line, but with their endpoint, they're actually going to extend infinitely in opposite directions. So in a minute here, you'll see I draw on the figure. I draw an endpoint that they're going to have in common. So here, the blue point, A, that's the endpoint they have in common. So right here, I have ray AM. Starts at point A, extends infinitely in the direction of M. And then on this guy, I have point A as the endpoint, but extends infinitely in the direction of R. So you can see that ray AR and ray AM, are opposite because they have that same endpoint. They're all on the same line, but ray AM extends infinitely in this direction, and ray AR extends infinitely in this opposite direction. And then I do believe I draw another pair of opposite rays, so I'm still going to use that endpoint A. And this time I'm going to put point L and X on the diagram. So another pair of opposite rays could be ray AL and ray AX. Those would also be opposite. However, ray AX and ray AR would not be opposite. They have the same endpoint, but the key is they are not collinear, which is part of the opposite ray definition. And I think I draw that in the diagram. So I show you, like, they do have the same endpoint, but the fact that they're not collinear, it rules it out from them being opposite rays. So now we're going to go on to naming points, lines, and planes. A point is very simple. You're just going to use one letter, and it's always going to be right next to the dot. So that would just be point A. For a line, you're going to use 2 points that are on the line. You could use any 2 points that are on the line. The order doesn't matter. And then you just see that symbol above has the 2 arrows at the end denoting that it's a line, and it goes off infinitely in both directions. And then for the plane, we use that little parallelogram symbol, and we have to use 3 points that are on the plane. And again, the order of the points doesn't matter. So plane BAC would be the same as ABC. Okay, wow. So looking at this diagram, we have a ton of points that are on the diagram. There's point M, point V, point N, point T, point W, point P. Now notice all these points are in the diagram. However, point T and point W are actually not on the plane. If you can see that, it's shown 3-dimensional, and that line TN is going through the plane, so T and W are actually not on the plane. The only other thing you'll notice is this little S right here and this little A. Those are not points because they do not have the dot next to them. This fancy S is a way to name the line, and then this A is another way to name the plane, but they don't have a dot, so we're not considering them points. This one here, name all the lines in the diagram. Again, this could be very time consuming because we have a lot going on, and we can name the 2 lines differently. So we could name this guy, this line MN, but it's really this. Okay, and then we can name this line WN. Let's put this over here. Because there's also, there's more than one way to name these 2 lines. We could name line MN, we could name it, we could list the N first if we wanted to. We can name it line NM. Or we could even use the P. We could name it line PN. So these are all different ways to name the exact same line because all we need to do is use 2 points that are on the line. It can be any 2 points. And the reason behind that is because the line extends infinitely in both directions. So no matter what points you use, it's going to contain those. And I probably missed some of the different ways to name it. So, like I said, line NW, line TN, line, what else did I choose? WN or WT, all naming that same line up there. And then to name the plane, you have to use 3 points. Now, the key is that they all can't be on the same line. So we could not use M, N, and P in this case because M, N, and P are all on the same line. So we have to make sure at least one of the 3 is a non-collinear point. So in this case, MNV would work. MPV. Notice you don't want to use T or W because T and W are not on the plane. So again, make sure they're on the plane, and then make sure one of them is not collinear with the other 2. All right, now if we talk about naming line segments. For line segments, I think this is probably one of the easiest ones. You just use the 2 endpoints, and the order doesn't matter. But for array, it does matter. So if I want to name the line segments in this diagram, there's a ton again. Look at the symbol. So I have the M, the segment symbol above there. And notice segment MN means the same thing as segment NM. Or if I talked about segment PN, it's the same as segment NP. Now notice, if I look at these two segments, if I look at the segment MN versus the segment MP, those are two different segments because MN is this portion right here, where MP would be this whole guy, this portion. So MP would be a significantly longer segment than segment MN. So segments are important. The endpoints are really, they're really crucial because if you change the endpoints, then you're changing the length of the segment, which results in a completely different segment. So yeah, NT or TN, segment NW or segment WN, those mean the same thing. All right, now we're going to look at different rays in the diagram, and we name the ray from its endpoint and then the direction we want to go in. So if this segment or this ray right here is ray MN, that means it's going to start at point M, that's its endpoint, and it's going to head in the direction of N infinitely. Now, I just named a second ray, ray MP. Ray MP and ray MN are actually the exact same ray because they have the same endpoint and it's extending in that direction infinitely. So since N and P are both in that same direction, these two are actually the exact same ray. But ray NP would be different because it has a different endpoint. So I'm just kind of naming all the different rays I see. There's probably more that I missed just because all you need is an endpoint and then the direction you're headed in. And again, like I pointed out earlier, these two rays right here, WN and ray WT, are another pair of the rays that are actually the same ray because they have that same endpoint and extend infinitely in that same direction. So opposite rays. Opposite rays have the same endpoint, and just like in their name, they extend infinitely in opposite directions. But the biggest thing again here is they are collinear. So let's say I'm looking at this diagram and I start with endpoint N and I want to head in the direction of P. So I ray NP. The ray that's opposite ray NP has to have the same endpoint. So we're going to have endpoint N again, and it has to be on the same line. So the only other ray that's opposite NP would be ray NC because it's collinear with it, it has the same endpoint, and it's extending in the opposite direction. And the other pair would be ray NA and ray NR. So if I name all the rays with endpoint J, there should be 4 of them. Because I could start at point J and I could go in the direction of E, I could go in the direction of G, I could go in the direction of H, or I could go in the direction of F. And then which of these are opposite? So take a minute, think to yourself, out of these 4 rays, which 2 are opposite, meaning that they have to be on the same line and they extend in the opposite direction, and they all do already have the same endpoint, so we're good there. So we'd have ray JE would be opposite ray JF, and then ray JH would be opposite ray JG. Okay, so since I'm on my iPad, it wouldn't display the content that was on the Smart Notebook. So this was just practicing determining if 2 rays were the same or if they weren't. So I'm going to write it up here in a second, what should have been on the lesson. So let's say I have ray LP and ray LK. Okay, kind of think to yourself, would these be the same ray? Why or why not? So they are indeed the same ray. It's because this ray, LP, starts at point L and extends infinitely in the direction of P. So it goes right through here infinitely. And this ray here starts at point L and extends infinitely in the direction of K, which is the same. So they are the same. All right, what about ray LP and ray PL? So right away, it should jump out at you that these are not the same ray simply because they don't have the same endpoint. So right away, they're not the same ray. All right, last but not least, we're going to just briefly talk about the intersection of lines. So there's 4 different cases that can happen when we're talking about lines intersecting or not intersecting. So the first case could be they just intersect each other, which is simply put, they just cross each other at one point. And again, this could occur with 2 or more lines. You could actually have an infinite amount of lines that intersect at one point. And I'll just draw a quick example. So there's one line, and then we have our other one, and you can see this point of intersection right here. A little bit more specifically, our lines could intersect and they could be perpendicular. So they are still lines that intersect, but what makes them a little bit more special is that they intersect at a 90-degree angle, or what we call that a right angle. And you'll be able to know if they intersect at a right angle. So I'm going to stop the video right here. This angle looks pretty close to 90 degrees. If this figure, I was doing a problem, or I was solving something with this figure, I cannot assume that that's 90 degrees. It might look very, very close, but in geometry, we always have to be sure. So we can't assume unless it's labeled, and the way it will be labeled is with this 90-degree box right there. That represents that this figure is indeed they intersect a 90-degree angle, and we can be sure. But if it's not labeled, then we can't assume, and again, it has to be labeled for us to be most accurate. All right, the third one is if 2 lines are parallel, and I'm pretty sure you guys have all heard of parallel lines before, and you know, okay, they don't intersect. But there is one more stipulation with parallel lines, just not being lines that don't intersect. They actually have to be coplanar, meaning they have to be on the same plane. And this is best represented by a cube. It's easiest to kind of see what I'm talking about. So this line here, this side of the cube, and that side of the cube are parallel. They'll never intersect, and they're both on the same plane. They're both on that top part of the box. So again, the cube is easier because if I'm trying to explain skew lines also don't intersect. Okay, these are another pair of parallel lines, sorry. But skew lines also never intersect, but they are not coplanar. So we have another case where we could have parallel lines that don't intersect, but they're actually not parallel. And I'll show you on the cube kind of what I mean by that, because it's kind of hard to picture without it. So we could have that side there, and then see how they are never going to intersect each other. This one's going off infinitely in this direction. This one's going vertically. But they're not parallel because they're not on the same plane. So that's where we get our definition of skew lines. And then there's another set I'll show you too. And there's other ones on the cube too. Those are just the only 2 that I actually illustrated. All right, so there's many, many options for this question here. This is just kind of a wrap up of lines that intersect or don't intersect. You'll see here at the end of the video, I put an example of each, but just know that there are way more than one answer for each of these questions. And then once I finish this guy, that pretty much wraps up section 1.1. Again, it's just being able to sketch, label, and know the definitions of all these new terms. So as we move forward, if you don't understand these definitions, it's kind of hard to be able to apply them when we look at problems dealing with this vocab. So make sure we get this vocab down so you can be more successful in the future sections.